Welcome back. Here's something that we've seen and worked with for many years. A number b raised to the power of another number c. This b is called the base of this expression, and the number c is called the exponent. Remember that when the exponent is a positive integer, we can think of this as the multiplication of c copies of the base. So b to the fifth is equal to b times b times b times b times b 5 times. If it's just b to the first power, there's just one copy of b, and so b to the first is equal to b. If we take 0 to the cth power, that's c copies of 0. 0 times 0 times 0 times 0, which gives us 0. And if our base is 1, then 1 to the cth power is 1 times 1 times 1 times 1, which is equal to 1. If instead we take negative 1 to the c power, we know that negative 1 times negative 1 is equal to positive 1. So the product negative 1 times negative 1 times dot 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 times negative 1 is going to depend on whether we have an even number of copies or an odd number of copies of negative 1. Negative 1 to the c is equal to 1 if c is even, and negative 1 to the c is equal to negative 1 if c is odd. So for example, negative 1 to the 33 is equal to negative 1 because 33 is an odd number. Let's talk about another case of b to the cth power when the exponent c is equal to 0. You may know that the answer is 1, but do you know why? Here's some intuition. When we take b cubed, we can write that as b times b times b, or in other words, we can write that as b times b squared. So that means that if we start off with b cubed and we divide by b, we get b squared. Similarly, if we take b squared, we write that as b times b, or as b times b to the first. We see that we divide b squared by b, and we'll get b to the first. Let's do that one more time. If we take b to the first, we can write that as b times b to the 0. And so if we want to get b0, we divide b to the first by b, and what's b divided by b? 1. And so whenever b is not equal to 0, b to the 0 is equal to 1. It's important that b is not equal to 0 because 0 to the 0 is not defined. Now what about when you have a negative exponent? We can use the same intuition we used above to figure out what b to the negative 1 should be. If we want to get b to the negative 1, we should divide b to the 0 by b. What does that look like? B to the 0 is equal to 1, and so b to the negative 1 is equal to 1 divided by b. So we conclude that b to the negative 1 is equal to 1 over b, and in general, b to the minus n is equal to 1 divided by b to the n. So if we had something that was b to the negative 5, that would be 1 divided by b times b times b times b times b 5 times. So what's 6 to the negative 1? It's 1 divided by 6. What's 2 to the negative 4? It's 1 divided by 2 times 2 times 2 times 2, or 1 divided by 16. What is negative 3 to the negative 3? We get 1 divided by negative 3 to the 3. So that's 1 divided by negative 3 times negative 3 times negative 3, which is 1 divided by negative 27, which is the same as negative 1 over 27. Exponents don't always have to be integers. When the exponent is a unit fraction, that is, the exponent looks like 1 divided by c for an integer c, that's the same as the cth root of b. That's the same as saying that if we write x is equal to b to the 1 over c, that is a solution to the equation x to the c is equal to b. We're especially used to this when we see things like x squared is equal to 11. The solution to that would be x to the square root of 11, which if we write that as an exponent, we write 11 to the 1/2 power. And if we want a solution to x to the 6th is equal to 2, the answer would be x is equal to the 6th root of 2. Sometimes we can get an exact number. So let's say we wanted to compute 64 to the 1/3 power. We would be trying to figure out what number cubed is equal to 64. Because 4 times 4 times 4 is equal to 64, then 64 to the 1/3 power is equal to 4. Let's stop there for now. See you next time.